Okay, there we go. Sorry, now we are. Okay, so we're on number 13, right?
Yes. Well, we're going over the chart, the numbers that we got here. Then we've got 0.82 is the deviation from the mean on the third one. Is that what you guys got?
I got 0.905. Let me check that.
Okay,
I got 0.819 if we have to go 3 decimal places.
I got 0.905.
Oh, the deviation. Are we doing the deviation or the squared deviation?
Deviation from the mean.
Oh, okay.
Oh, yeah, you're right. I don't know how. So that's 0.905. Shucks, that means my, okay. 905. 0.905. And then 0.819 for the squared deviation.
Yeah.
Yeah.
Yep.
And then and then 0.085 for the deviation from the mean.
Yeah.
That's what I got.
And then 0.007 is the squared deviation.
Yeah.
Yeah.
Okay, perfect. So my number 14 is going to be a little bit off because one of my numbers wasn't right. So we'll have to fix that. But let's go to 13. 13 says what quantity is equal to the sum of the numbers in the squared deviations column. So this one was.
I put none of them.
I put none of them too.
So did I, because variance, you have to do that division.
Correct.
Yeah.
And I haven't done it if it's just summed.
Perfect. Okay. So then 14 would be, I'm going to rework this really fast.
I have 0.715.
For the standard deviation?
Yeah.
What did you get for the sum of the squared deviations?
For the sum, let me look. I think I put it down here. Nope, I messed up. Let me check and see if I wrote it on my paper.
Did you guys get 1.777 for the sum?
Let me look. Let's see if I can find it easy.
Hang on, I got 1.534. So, but let me do that math again.
That's what I got, Jim, too.
It is what you got. 1.534.
Yeah.
Okay. 0.681 plus 0.81.
Yeah, I got 1.534.
Yeah.
For the sum.
For the sum.
So how do you find the deviation?
So then you take that sum and then you divide it by n minus 1. So you're going to have divided by 3. And then you take the square root of that number point. So I get 0.715 is the standard deviation. Is that what you guys get?
That's what I got.
Okay. So do you remember that, Jen, that the formula for that?
I don't, but I just.
So the variance equals the sum divided by the n minus 1. And then the standard deviation is the square root of that answer.
What is the variance exactly? Like, what is it?
The variance is where those numbers kind of land from the mean, is what I understand it to be. So the variance is going to be all of your sum of all of your squared deviations divided by n minus 1. That's what the variance equals.
And then the standard deviation is the square root of that?
Uh-huh.
Okay.
Perfect. Okay. And you guys got 0.715, right, for 14?
Mm-hmm.
Yeah.
Great. Okay. Okay, are we ready to move on to 15?
Yes.
Okay, under certain conditions, the standard deviation can be negative.
I put true.
True.
Yes, I also put true.
Let me.
Because if you think about our probability applet,
Yeah.
that number that we put on the left side is a negative.
Let me pull up my notes. It seems to me.
The probability can't be negative, but the standard deviation could be negative. That's what I understand.
Okay. I was thinking.
Honestly, I wasn't 100% sure on that one.
I was thinking that standard deviation couldn't be negative, but I'm not finding the notes that I have that would tell me that.
Nope, it can never be negative.
Okay, so we're going with false here. You know what? I think in my mind, I was thinking more of along the lines of like z-scores and
that's what I was thinking too.
different things like that. But now that I really think about that question, that I don't think we've ever seen a negative standard deviation. So
There it is.
Even if it goes to the left of the mean, it's still one standard deviation.
Yeah, that's right.
It's always stayed. You're right. That's right. That makes sense.
And if the standard deviation is 0, then all the values are identical.
Okay.
So, yeah. Okay.
Perfect.
Where did you find that in your notes, Jennifer?
Not in my notes.
No. Other
Me?
Jennifer.
Oh, yesterday I was working on getting my note page ready.
Uh-huh.
It was in one of the lessons. I think I got up to like lesson 2 or 3 yesterday.
Okay.
One of those.
Okay.
Yeah, that makes sense. Okay, let's see, number 16. Which location resulted in the most consistent temperature measurements from one sill to another? I put the extradural because the standard deviation was the smallest. Is that right?
That's what
I got too. It doesn't really make a whole lot of sense though. You'd think that the arterial would have less change, but apparently with stills it's different. Because extradurals, like on the outside of the skin, you'd think they jump in the water and it would change a lot, but
right.
That's what had the least change.
Okay.
Weird.
17. Let's see. What is the third quartile? Q3.
I think it's 8.
8.
Yeah.
Q1, Q2, Q3. Yep. Question number 18 is what percentage of the data lies between 4 hours and 8 hours? List the number as a percentage and not as a decimal. So between 4 hours and 8 hours,
I put 50%.
is 50%. Because that's between 25 and 75, right? Q1 and Q3.
Yeah.
Yeah.
Okay. So don't include the percent sign. So we're putting what, 0.50?
No, just 50. It says if the answer is 66%,
sorry.
then input 66, not 0.66.
Thank you. All right, question. So this one was, we're looking for the mean. Did you guys get the mean was 2.055?
Yes.
Yeah.
Yes.
And that we just took the two numbers that they gave us, 1.59 and 2.52, and then did the mean of those two numbers, correct?
That's what I did.
How I did it.
Perfect. Next one, estimate the standard deviation of the measured nitrate concentration. So I got 0.2325.
I got 0.23.
What did you get?
0.23?
I got 0.233.
Yes, that's exactly what I got, but just rounded to 3 decimal places.
Okay, so how did you get that?
So I wrote by hand one of those
One of those charts?
the bell curves with the chart, and I put the mean in the middle, and then I put the values that we knew, 1.59 and 2.52, and kind of I ended up just finding the value in between those two, if that makes sense. So I think what I did was I divided it, and maybe Jennifer has a better process of how she came to it, but
how we did it.
Okay, that makes me feel better then. So
Yeah.
I just found the middle number between the mean and the lower value they gave us and the mean and the higher value they gave us and went right in the middle.
That's how I did it.
Okay.
And then
I did not do it that way. So
how did you do it?
Estimate the standard deviation of the measured nitrate concentration. So we're looking for the standard deviation of those two numbers, right?
Mm-hmm.
Correct.
So I did it just like the chart before, where we had the, for the seal's body temperatures.
Oh, like a chart?
Yeah. Is that not the right?
So
I mean,
what numbers did you
So
input?
I did 1.59 minus the 2.055, because the 2.055 was the mean that we had gotten. And then 2.52 minus 2.055. And then I got a negative 0.47 and a positive 0.47. So then I did, I squared both of those numbers, and I got 4418 divided by 1 equals 0.4418, and the square root is 0.665. But I don't know if that's the right way to get, if that's what they're asking.
So you were saying that what was the standard deviation? 0.665?
Uh-huh.
I don't know.
So what did you say?
Jeannie, what did you then get for 22, which was the...
Well, that's where I'm stuck right now. So...
Okay. So here's something way to kind of test your standard deviation is to make that chart and put the mean. And if you do it by your standard deviation and you go out, you remember the 68, 95, 99.7 rule?
Yeah.
So with question 21, it's going to ask us what is the 68% values on that chart. So if you use your standard deviation and you go out, you should be able to have the values that they gave us, which was 1.59 and 2.52 in your graph, in your chart.
Okay, so how do you show me how you do the can you put your paper up and show me how you do that graph? Because I don't get what you're saying when you say that you drew a picture and...
Okay, let me pull up my thing so I can see what I'm looking at here. So I can't see this if you can.
Yeah, I can.
I'm covering up my own screen. Can you see that chart?
Uh-huh.
So that's the chart where the first lines are 68%. So one standard deviation out from the mean is the 68%. Two standard deviations out from the mean, which is the standard deviation times 2 on both sides. And then the one furthest out is going to be the 99.7% rule. Does that kind of make sense?
Yeah. Hey, put it back up there. Let me take a picture of it with my phone, and so I can look at it. Okay, so say something so your screen is up there.
Can you see that?
Yeah, okay.
So basically, I just kind of filled in the values that I knew and then solved for the values that I didn't have yet, but that we needed. And I wasn't sure if I was doing it right, but I think it works.
So I still don't know the standard deviation for 21.
I got
the standard. Sorry, go ahead, Jennifer.
I got 0.233. Is that
I got that as well?
Okay, you cut out when you were talking, so I still don't know it.
0.233.
233. And you got that how?
I did the same thing that Erica did. I did a little, I don't know if you can see it, it's pretty light, but I did a little chart thingy.
Okay.
And I did, I put in what we knew, which were the ones on the outside. And then I divided it in half. That gave the mean.
Oh, because those numbers on the outside were 2 standard deviations, right? Is that where you got that information?
I can't even remember what the question says. Yes.
Okay. So that makes sense to me.
Yes. So it tells you in the question that it's 2 standard deviations from the mean. I'm pretty sure.
Okay. That makes sense to me.
So then I just took each of those that were 2 standard deviations away from the mean and subtracted it from the mean, or subtracted the mean from them, and that was my deviation, if I remember correctly. That's how I did it. And then I went through and checked and figured, okay, if that's right, then from the mean, minus the standard deviation, that'd be 1 deviation, and another one should get me the original number that they gave us, and it seemed to work out. So I assumed
so with the mean being 2.055 and 2 standard deviations away from that to the left is 1.59, right? Yep. Okay, so tell me how you got that first standard deviation. What was the math that you did?
I took the mean and subtracted the 1.59.
Uh-huh.
Actually, yeah, and then I just
and then divide it by 2.
Yeah, and divided by 2, and that gave me the deviation. So then I would take the mean and subtract the 0.233, and that would give me the one in the middle.
0.233. Okay. So then, so 2.055 minus 0.233. So your first number to the left is 1.822.
Yes.
Okay.
Yeah. I actually got 1.823, but
Okay.
yeah.
And then 2.055 plus. And then the other one is 0.28. Did you put 289 or 28?
I got 2.289.
89.
That's
Okay.
what
Okay. All right. Thank you. I appreciate that.
So you got 2.289?
For the first number to the right of the standard deviation.
Because I got 2.287.
That's probably just a matter of somewhere along the lines it got,
Rounded or something.
you know, rounded or something like that. But you'll still get the same, you know, because, well, at least in these ones, I just rounded to 2 decimal places, because in the original question, they had 1.59 and 2.52. So I just rounded everything to 2 decimal places. At the end, when, especially for number 22, when I came up with the variables for at the 68% variables.
Mm-hmm.
Okay.
So the standard deviation that I have is 0.233 for number 20 on the quiz.
Yep.
Okay.
You're talking about the quiz now?
Yeah. Okay, so
Yeah.
between what two measure? Okay, so I have 1.823 and 0.288. Okay.
So you guys, for number 21, it's the bottom one. Is that what you guys got?
Yeah.
Yes.
Yeah.
Okay. Perfect.
And then it doesn't ask on here on the quiz online, it doesn't ask number 23, right?
Doesn't look like it.
Okay, but so what is the mean and the standard deviation of the standard normal distribution? So would that just be 2.055 and for the mean, and then the standard deviation would be 0.233?
No, the mean for any standard normal distribution is going to be 0, and the standard deviation is going to be 1. Because they're asking for the mean of the standard normal distribution,
Yeah.
not the estimate, not the mean of the measured nitrate concentration.
Okay.
So
Jennifer, can you say that one more time?
The mean of any standard normal distribution is going to be 0, and the standard deviation is going to be 1. So they're not asking for the mean of the nitrate concentration. They're asking for the mean of the standard normal deviation. And that's how Erica and I were able to figure this out, because we knew that 0 is the mean of any standard deviation, which is just that curvy do, and that the ones the standard deviations 1 and 2 are going to match up with the standard deviations that they gave us for the nitrate concentrations.
Okay.
Does that make sense?
Yeah. I remember reading that this morning about the mean and standard deviation are 0 and 1. So, yeah. Okay.
Okay, so let's see, we're on number 22 on the quiz now, which I believe is 24 on the review that we did.
Mm-hmm.
And I got 0.5.
Yeah.
Mm-hmm.
Did you guys all get that? Are we good with that one?
Yeah.
Or any questions on how we did that? Okay. Then the next one is asking, what is the probability the randomly selected student will score below 600? I got 0.684, 0.684.
That's what I got. I think I have a negative, but maybe that's not.
So do we do the 3 decimal points, just 0.684?
Uh-huh.
Uh-huh. Let's see.
No, I think, no, I have a negative written down there, but I don't think that that's right.
Probability can't be
Negative.
It can't,
Yeah.
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 Because it's a percentage of
I
the
think I
students
had
that score.
another number there and erased it, and so it looked like a negative sign.
Okay, and then the next one is if they'll score 600 or above, I got 0.316.
Yeah, that's what I got.
And you can do that on the probability applet, or you can subtract 1 minus 0.684.
Right.
The next one, find the GMAT score that corresponds to the 10th percentile. I got 387.768.
So 388.
Round to the nearest whole number. Okay, so that would be, yes, 388.
That's what I got.
That's
Okay.
what I got.
The next one, let's see if I'm rounding that to a whole number, would be 697.
Yeah, that's what I got.
Okay. The next one would be 461.
Yeah.
Yeah.
And that, if I wasn't sure if I was doing that right, but when it asks for that, it's just asking for the 25th percentile, right? So it's the same process, but just using 25%.
That's how I did it.
Okay.
Yeah, that's good.
And then the third quartile is going to be 624.
That's what I got here.
I put 623 because I had a 623.06.
I had 63.54.
Okay.
I had a, 623.54.
Okay.
So 620, let's see, yeah,
624.
624.
Yeah.
And then let's see, the next one I got was, let's see, my 31.123.
Yep.
No, sorry, the mean. We're looking for the mean, right?
Yeah.
I got 542.3.
2.3.
Yeah, that's what I got.
542.3, okay. And the last one, I got 0.0319.
That's not what I
I
got.
got 0.0313.
I got 0.032.
So
You
that,
guys,
if I round to 3 decimal places, Jennifer, then that's what I got too. Because
Yeah.
0.0319 will go to 0.032. So what does she want us to do here? 3 decimal places. Yep.
can you guys tell me how you got that, please?
.032, sorry, here we go. Yes, so on 32, they're looking for, let me just go back to the problem real fast. They're looking for the probability that the sample GMAT score, so they're wanting us to use the same mean and everything from the question above, but now we're taking n equals 15. So they're taking 15 students from all those students that they're wanting us to sample. So you'll sorry, what, Jennifer?
So I was looking at question 31, well, sorry, on the homework, because it asked for the mean and the standard deviation of the distribution. So on the quiz, we only had to answer what the sample mean was. What did you guys get for the standard deviation?
I got 31.12.
Me too.
Yeah.
Okay, so yeah, that's the part I didn't.
So for that, you'll take your standard deviation, which was 120.54. And now that we have that sample of n equals 15, you have to divide that by the square root of 15 to get that standard deviation.
And that will give you the 31.12.
0.123, yep.
Okay. Okay, so what was the answer for the next one?
0.032.
Yeah, okay, because I got 19.
And then do you understand, Jennifer, how we got number 32?
Yeah, I know how to get that. I have a hard time with the standard deviation thing.
So what did you get for the z-score for that?
For what?
For 32. Don't you have to get the z-score to get the standard deviation?
So I had 1.8539 for the z-score.
That's what I had for my z-score for 30.
Me too.
I had 1.862, and I've done it 3 times. So
what are your exact numbers in your equation?
So I'm using, what is the probability that the sample mean GMAT score will be greater than 600? So I'm using 600 minus the, is it 542.3? Maybe I have that number wrong. No,
no, that's right.
Okay, minus 542.3 divided by 120 divided by the square root of 15. Oh, it's 120.54. That's what I did. Okay. See, these are the things that are going to kill me on the test, are these kind of stupid mistakes that I make.
That's the thing about math. There's so many little things you have to watch for, and negatives and decimal points. It's so easy to.
Yeah.
Okay. What did I do?
600 minus 5.
So on number 30, the answer is 31.1. No, 31.12.
On what?
On question 30 on the quiz.
Let me go to the quiz.
No. So you're looking at the standard deviation. So 31.123 is the correct standard deviation, but they're wanting the mean on question 30, not the standard deviation.
Oh, question 30. What is the standard deviation of the distribution of sample mean scores for all such samples? So they want the standard deviation, but they want it for the distribution of the sample mean scores.
Correct.
What did you guys get?
Okay. I got 31.123.
Yep.
For this deviation of.
And then number 31 is the 0.032.
0.0319, right? That's okay.
But you round to 3 decimal places, it says.
So 0.031, 0.032.
Yeah.
Okay.
So on the group quiz on the computer, question number 30 is 31. see, are we going to 3 decimal
Oh,
places?
31.12.
1, 2, 3.
Yeah, because you round to 3 decimal places, so you'll have to have the 3 on there.
1, 2, 3. And then
And
31 is the 0.032.
Yeah, the probability.
Okay.
Perfect. Okay. So do we feel good about all of our answers? Should I submit this?
Yeah.
See what happens. All right, I'm going for it.
All right. You're the brave one.
Wow, we got them all right.
Awesome.
That's good. Okay, guys, so when we take our exams, I think we're given like 4 hours. So I think it's important that I think we all understand how to do everything pretty well in the process, but it's just those little, and especially for me, like it's just those little things. So make sure that we do it. We have a lot of time, so make sure you do everything multiple times just to make sure that you're getting the right, right answer. And that's main advice for myself because I've got to do that.
I have a question for you on, okay, so I'm going to stop the broadcast, I guess, since we've got that taken care of. But this goes back to the